Hello and welcome to our lesson on radicals to exponential form with variables. First, let's talk some definitions. A radical is an expression, so no equal sign, that includes a number or a variable, a radical or root sign, and an index. Remember, the index is the teeny tiny number. I've got my variable and my coefficient, and there's an exponent as well, and all those are the radicands, and then it's all underneath the radical sign. A radical term can be written in exponential form. This is when the numbers and variables become the base, the big number, right here. See, the 64 became the big number? The index becomes part of the exponent as well, and I'll explain how that's going to happen in a second. The radicand becomes the base, so we just talked about that, the big number. The index becomes the denominator. This little guy right here moves to denominator position. The exponent to the radicand, this little guy right here, becomes the numerator to the new exponent, and the radical sign disappears and becomes a division sign of the exponential fraction. So 64 is the base, it's the base down here. And then I've got x, and that transfers down as well. I've got an index of 2. Notice I have 2 here and 2 here because it's 64 times x, so both the 64 and the x, both the coefficient and the variable, have to have an exponential fraction. 3 was attached to the x only, so 3 becomes the numerator of the x. And there is no exponent here, so it's assumed to be to the power of 1, which is why 1 became the numerator for the 64. Notice how the exponent is only attached to the variable of x, that 3, and not the coefficient of 4. That means that the x variable only is being cubed, not the coefficient of 64. This is what it would look like. The original example, where it had exponent as 3, is still attached only to the x variable. It didn't move over to the 64, and that's very important to watch. So wherever the exponent is attached to, it stays to that variable only and not to any other thing underneath the radical sign. Let's take a look at an example. I've got 10x to the 4th. So that means I have 10 and I have x, and those are both the base. 10 did not have an exponent, so it's assumed to be 1. X did have an exponent, so it's 4. Those both become numerators. There is no index, so we know that it means 2. The index becomes the denominator. And if you notice, 4 over 2, we can reduce that. So this would become 10 to the 1/2 and x to the 2, or x squared. This would be your exponential form of writing this radical. Now onto the second one. We've got a 54 and a y cubed. So 2 separate terms that need to have 2 separate exponents. We've got 54 with an exponent of 1, because it's not written, it's assumed to be 1. Then we've got our variable of y with an exponent of 3. This time they did write an index for us, so the index becomes the denominator. So you've got 1 over 4 and 3 over 4. Now the fractions can't be reduced any further, so this would be your exponential form of this radical. Let's just try 2 more. We have a decimal, which is fine, that can still be a base. You have 24.5. There's no exponent attached, so it's assumed to be a 1. Then we have z as our variable, and it does have an exponent of 8. So those 2 exponents become numerators. They did give us an actual index, so we're writing it as 5 on denominator position for both of the variable and the coefficient. And you also have a negative sign, so the negative sign needs to also go into your answer as well. So it turns out that this radical converted to exponential form is negative 24.5 to the 1/5 times z to the 8/5. And then, let's do the last one, we have a fraction. Just because it's a fraction means that in your answer it needs to stay a fraction as well. So let's focus on the numerator first. You have 64, no exponent, so it's assumed to be a 1, and then m to the 10th. There is no index, so we know it's going to be a 2. So the index becomes your denominator. Now that was all the numerator from the original radical. Now we have to look at the denominator. We've got 16 This time we do have an exponent, so that's our new numerator. And then we've got m to the third. And again, our index is assumed to be 2, so that becomes our denominator. If you notice though, m to the 10 over 2 can be reduced. So can 16 to the 4 over 2. If we reduce it, we end up with 64 to the 1/2, and then we have m to the 5th because 10 divided by 2 is 5. On the denominator, you've got 16, 4 divided by 2 is 2, so it's 16 squared, times m to the 3/2. You've got the negative sign, so it needs to go into your answer as well. So here is your exponential form for the radical. Quick review. The radicand becomes the new base, the new big number. The index becomes the denominator, so he goes on the bottom of the new exponent and it's attached to the base. The original exponent attached to the radicand becomes the numerator, so this exponent becomes the numerator, and the radical sign changes to a division sign for the new exponential function. So it's really BEI. And that's it for our lesson on radicals to exponential form with variables.